Jupiter, colossal enigma of the solar system. What the Juno spacecraft revealed about the gas giant. Over 1,300 times. That's how many Earths could theoretically fit inside the mighty expanse of Jupiter. This figure alone underscores the sheer magnitude of the gas giant, the undisputed monarch of our solar system. Yet, despite its gargantuan size and centuries of observation, Jupiter remains shrouded in mystery, a world of turbulent storms, powerful magnetism, and unanswered questions. To lift the cosmic veil surrounding this colossal planet, NASA launched the Juno spacecraft, a state-of-the-art probe specifically designed to study Jupiter's atmosphere, magnetosphere, internal structure, and origin. Since entering orbit around Jupiter in 2016, Juno has transformed our understanding of this behemoth, and along the way, uncovered phenomena so strange and unexpected. Even seasoned scientists were left stunned. A giant wrapped in secrets. Jupiter has been known to humanity since antiquity. Bright and majestic in the night sky, it has been chronicled by ancient astronomers across civilizations, from Babylonian star charts to Galileo's groundbreaking telescopic observations in 1610. Yet even with centuries of data, many of the most fundamental questions about Jupiter have remained unanswered. With a diameter of roughly 143,000 kilometers at its equator, Jupiter is more than 11 times wider than Earth. Its mass is 318 times that of our planet, and it holds more than two-thirds of the total planetary mass in the solar system. Despite its size, however, Jupiter is a gas giant. It has no solid surface, and is composed primarily of hydrogen and helium. Before Juno's mission, large swaths of the gas giant's atmospheric structure, especially in the polar regions, had never been closely examined. The same applied to its magnetic field, which is the most powerful of any planet in the solar system. To solve these puzzles, Juno was equipped with instruments designed to peer beneath Jupiter's dense cloud tops and to detect the planet's gravitational and magnetic fields with unprecedented precision. The mythology behind the mission. NASA named the spacecraft Juno after the Roman goddess who was wife to Jupiter, the king of the gods. According to myth, Jupiter used a veil of clouds to hide his mischief from Juno. But she, wise and perceptive, could see through the mist and uncover what lay beneath. The metaphor is perfect. Juno, the spacecraft, was sent to strip away the layers of mystery concealing Jupiter's innermost secrets. Launched on August 5, 2011, Juno took nearly 5 years to reach Jupiter, finally entering orbit on July 5, 2016. But instead of taking a simple circular route, Juno was placed into an eccentric polar orbit, allowing it to repeatedly dive close to Jupiter's cloud tops, sometimes as close as 200 kilometers, before swinging back out to safer distances. This unique orbit allowed Juno to gather a wide range of data from many latitudes and altitudes, while avoiding Jupiter's intense radiation belts as much as possible. What it found during its daring flybys would not only challenge previous assumptions, but in some cases completely upend them. Stormy realms. Jupiter's violent and vivid atmosphere. One of Juno's earliest and most breathtaking revelations concerned Jupiter's polar regions. Before Juno, scientists had assumed that the familiar zonal wind bands, the horizontal stripes that dominate Jupiter's mid-latitudes, would continue all the way to the poles. But Juno's high-resolution imagery and data showed something vastly different. Instead of bands, massive cyclonic storms dominate the poles. These storm systems are enormous, reaching up to 1,000 kilometers in diameter at the North Pole and 1,400 kilometers at the south. Arranged in geometrically fascinating patterns, these vortices form persistent clusters, including an octagon-shaped arrangement at the North Pole and a pentagon at the south. These storms, some of which are larger than entire continents on Earth, appear to be stable and long-lived, surviving for years. Juno's camera, JunoCam, sent back stunning, surreal images of these storm systems, whirling clouds in shades of blue, gray, gold, and white, appearing like abstract masterpieces painted by a planetary hand. The lighter blue areas in these images represent high-altitude clouds made of ammonia ice and water crystals, casting shadows on the deeper, darker cloud layers beneath them. This dynamic, chaotic polar weather stands in stark contrast to Saturn, where the poles are defined by well-structured features like the famous hexagonal jet stream at the North Pole. Jupiter shows no such symmetry. The differences suggest that the atmospheric dynamics of the two gas giants are fundamentally distinct, perhaps due to differences in internal heat, rotation rate, or planetary composition. A magnetic monster. Another area of surprise was Jupiter's magnetic field, the strongest of any planet, extending millions of kilometers into space and generating intense radiation belts that would be lethal to humans. Juno's instruments revealed that Jupiter's magnetic field is almost twice as strong as previously estimated, with localized areas where the field strength and structure vary dramatically, a phenomenon referred to as clumpiness. The data contradicted the earlier assumption that Jupiter's magnetic field was smoothly distributed and generated uniformly by a metallic hydrogen dynamo in the planet's interior. Instead, Juno showed that Jupiter's magnetism is more lumpy and asymmetric, suggesting a complex and perhaps layered dynamo structure, another puzzle that scientists are still working to decode. Where is the core? Before Juno, scientists widely believed that Jupiter had a solid core of heavy elements, roughly Earth-sized, hidden beneath its deep layers of gas and liquid. But Juno's gravity measurements provided a startling twist. There was no evidence for a distinct, compact core. Instead, it appears that Jupiter may have a diluted or diffuse core, a large region of heavy elements that is not concentrated, but spread across a vast interior volume. Some models suggest this region could be half the size of Jupiter itself. The heavy elements may have mixed with lighter elements during the planet's formation or due to later impacts. As Scott Bolton, principal investigator for the Juno mission, put it, "We don't see anything that looks like a core. Maybe it's much bigger. Maybe it's half the size of Jupiter." This revelation challenges existing models of how giant planets form, particularly the core accretion model, and opens new questions about whether Jupiter's formation was the result of gradual accumulation, gravitational collapse, or a hybrid process. Jupiter's spectacular auroras. Mystery solved. While Earth's auroras are a well-understood phenomenon, Jupiter's auroral displays, the most powerful in the solar system, had long baffled scientists. Unlike Earth's auroras, which occur around both poles in a symmetrical oval, Jupiter's polar lights are offset and irregular, pulsing in strange rhythms that can last for several days. Working in tandem with the European XMM Newton X-ray telescope, Juno finally cracked the case. The culprit? Electromagnetic ion cyclotron waves, generated when the solar wind compresses Jupiter's massive magnetosphere. This compression sends oxygen and sulfur ions, originating from Jupiter's volcanic moon Io, hurtling along the planet's magnetic field lines. These ions are accelerated in bursts, eventually colliding with Jupiter's upper atmosphere and producing the glowing spectacle of its auroras. This multi-stage process, involving interactions far beyond Jupiter's immediate environment, is unlike anything seen on Earth. And scientists believe similar mechanisms may drive auroras on Saturn, Uranus, and Neptune, hinting at a universal process among the giant planets. The wet giant, clues to Jupiter's formation. One of Juno's primary objectives was to help determine how much water exists in Jupiter's atmosphere. This question is critical to understanding the planet's origin. If Jupiter formed quickly from the solar nebula, its elemental makeup should resemble the Sun. But if it grew gradually by accumulating icy planetesimals, it would contain more water. Using its microwave radiometer, Juno detected a surprising abundance of water, especially at the equator, where the water concentration was measured at around 500 parts per million, or 0.25% of all atmospheric molecules. That's roughly 3 times the water content of the Sun. This finding contradicts previous data from the Galileo probe in 1995, which sampled a relatively dry region and led scientists to believe Jupiter was parched. Now it seems Jupiter might be wetter than we thought, and this could reshape theories of planetary formation. The journey ahead. ESA's JUICE mission. Though Juno has answered many questions, it has also raised new ones. Are the water levels uniform across the planet? What role do the deep atmospheric flows play in its dynamics? What more can we learn about the diluted core? Fortunately, the exploration of Jupiter is far from over. In April 2023, the European Space Agency ESA launched the JUICE mission, Jupiter Icy Moons Explorer, which is set to arrive at Jupiter in July 2031. Unlike Juno, JUICE will focus on Jupiter's moons, Europa, Ganymede, and Callisto, investigating their subsurface oceans and evaluating their potential to support life. However, it will also continue studying Jupiter's atmosphere and magnetic field, building on Juno's legacy. Final thoughts. Jupiter, the enigmatic titan. Jupiter, the giant that once seemed familiar from afar, has now revealed itself as a dynamic, complex, and utterly alien world. Thanks to Juno, we now know that Jupiter's magnetic field is more intense, its storms more chaotic, and its core more mysterious than we ever imagined. As Scott Bolton aptly said, "No sooner did we think we understood Jupiter than it reminded us how much we still have to learn." The king of the planets continues to humble us, not with answers, but with deeper questions, reminding us that even in our own cosmic backyard, the universe still holds wonders beyond comprehension.